So in this video, we're talking about differential equations and slope fields. So differential equations are basically just equations that are derivatives. There's quite a few things here that are going to show up that you should know. And the first question here is really the only question that is supposed to be using a calculator on this whole packet. Okay, so it says population y grows according to the equation dy dt equals k times y. That is one of those things that we said you should know. K is a constant and t is measured in years. If the population doubles every 10 years, then the value of k is. Well, I hope you recognize that this is actually PERT. Now, we don't use PERT as our equation. We had y equals y sub 0 e to the kt, but it's still the same thing. So if we're doubling every 10 years, I hope you agree that time is 10, and doubling means that whatever we put in, or whatever the population was, it means that it doubles. So if the population was 100, in 10 years it would be 200. So you could make this 200 equals 100 e to the k times 10, because in 10 years the population would double. You don't even have to do that if you remember that that's going to equal 2. So now we have this equation, 2 equals e to the 10k that we have to solve. And we're going to natural log both sides. So we end up with the natural log of 2 equals 10k. So we divide by 10. And this is the only time in this entire video that you're using your calculator on this whole packet. So I'm taking natural log of 2 and dividing by 10. And I used diamond enter and got 0.069315. So A would be our solution. We're going to include number 2 for homework. Number 3. If dy dx is equal to sine of x times cosine squared of x, and y is 0 when x is pi halves, what's the value of y when x is 0? So this is giving us an initial point, and we're given the derivative. So we're supposed to find y, basically. So I'm going to do the antiderivative of this, but to do this, I'm going to think about u squared. So really, I'm taking the integral of sine of x, cosine squared of x. So I'm going to use u substitution. So I'm going to use my u as cosine, because that's the quantity squared. The derivative of cosine is negative sine of x dx. And when we look what matches up, we do have sine of x and dx, but we don't have that negative. So we need to make this negative du equals sine of x dx. So now I have the integral of negative u squared du. Keep my negative. To do an integral, we take the antiderivative, which means I add 1, but then I got to throw 1/3 out in front, plus c. So y is equal to negative 1/3 u cubed, how about cosine cubed of x plus c. So that's my original equation. Then I can use this initial value to find c. Y is 0 when x is pi halves. So cosine of pi halves, you got to know these, cosine of pi halves is going to be 0, so c is going to be 0. So I technically have y equals negative 1/3 cosine cubed of x plus 0. Now it says, what's the value of y when x is 0? So when I put 0 in for x, cosine of 0 is 1, and 1 cubed is still 1, so I get negative 1/3. So that is letter B. Number 4, the rate of change of the volume of water in a tank with respect to time t is directly proportional to the square root of the volume. Okay, so first of all, we have rate of change of volume. That's dv dt. So that allows us to cross off A and B. Is directly proportional to means that I have something times, so this is k times the square root of the volume, which would be letter E. we're going to add number 5 as a homework question. And then we are going over to number 6. My packet had number 7, the answers, missing. So if you need to do number 7 and you're missing the answers, because that's going to be for homework, make sure you record these or look at these. Okay, so number 6 says, shown above is a slope field for which of the following differential equations? And if you remember back when we did slope fields, the easiest thing to do is look where the slopes are 0. So in this problem, do you see that we have a 0 slope here when x is 2 and y is negative 2, it looks like? We also have a slope here when x is negative 2 and y is 2. So it looks like when x is positive and when y is negative. So we get something like x equals negative y. So think about that. We also could substitute in here. So if we put x in here in letter A, if we put negative or positive 2 in for x, do we get 0? No, we get a slope of 3. So that's out. If we put 2 in for x squared, do we get a slope of 0? No. Substituting x being 2. So now here for letter C, if I substitute 2 for x and negative 2 for y, 2 plus negative 2 is 0. So that's probably my answer. If I plug in 2 for x and negative 2 for y, do I get 0 here? Nope, so D is out. And if I plug negative 2 in for natural log of y, that's out because we can't take the natural log of a negative, so it's got to be letter C. So you're looking to see where are those flat slopes, and then you're analyzing from there. You, again, like I said, you're going to do number 7 for homework. And you are also going to do 6 and 5 for homework on this page. And these X bars, I think I told you before, this is what the average score was in the entire world on that problem, the year that they were given these exam problems. We are going to do this one together. So it says, consider the differential equation dy dx is equal to y minus 1 over x squared, where x is not equal to 0. On the axes provided, sketch a slope field with the given differential equation at the 9 points indicated. So I'm going to make a t-table, if you remember, and I'm going to have x, y, and dy dx on my t-table. So my first 3 points are right here. It's when x is negative 1 and when y is 0, 1, and 2. Then my next 3 points are when x is 1, and then I have 0, 1, and 2 for y. And then they also have 3 points when x is 2 at 0, 1, and 2. So I'm substituting these in. So I'm putting negative 1 in for x for this first one. So negative 1 squared is going to be 1 on the bottom always. And I'm putting 0 in for y. So 0 minus 1 is negative 1 over 1, which is negative 1. And then I have 1 for y. 1 minus 1 is 0 over 1, which is 0. And 2 minus 1 is 1 over 1, which is 1. Same thing, when x is 1 now, my bottom is still going to be 1. So 0 minus 1 is negative 1 over 1. 1 minus 1 is 0 over 1, which is 0. And 1 over 1, which is 1. And then finally, when x is 2, we're going to have a 4 on the bottom. So 0 minus 1 is negative 1 over 4. 1 minus 1 is 0 over 4. And 2 minus 1 is 1 over 4. So now we have our slopes, and we're supposed to sketch them on these 9 points. So when x is negative 1 and y is 0, I'm drawing a slope of negative 1. Negative 1, 1, I have a slope of 0, and negative 1, 2, I have a slope of 1. 1, 0, I have a slope of negative 1, 0, positive 1. Then I have negative 1/4, so remember you can think of it as going from here up 1 over 4. Zero, negative 1/4, or positive 1/4. So for those, you typically, to get points for that, you just need to have those main those main values. You don't have to do anything else. You don't have to show the table, but you want to do the table. Okay, letter B says, find the particular solution y equals f of x to the differential equation with the initial condition f of 2 equals 0. I get so many people that will screw this up. That's the point, 2 comma 0, x is 2, y is 0. And think about this. It says find the particular solution y equals f of x. Take these extra words out. It says find y equals. It says find y equals f of x. You were given the derivative. You're supposed to find y equals. So I hope you remember that we use antiderivative. And because there's an x and a y in this problem, we separate the variables. So I would divide by y minus 1. It would leave me 1 over x squared with my dx on the other side. So then I'm going to do the integral on both sides. Well, before I do that, I'm going to think of this as the integral of of x to the negative 2. Okay, so when I taught you to do these, we do the antiderivative. The antiderivative of 1 over y minus 1 is the natural log of absolute value of y minus 1. The antiderivative of x to the negative 2, we would add 1, but then we'd have to put a negative 1 out front. Don't forget then we put a plus c with the x and only the x. And then in the past, I've told you from this point to go ahead and plug in your values of x and y to find c. So I'm going to rewrite this, and I'm going to plug in my value of x being 2 and y being 0. So I get the natural log of 1, which is 0, equals negative 1/2 plus c. So c is going to be positive 1/2. So once we do that, I like to go back to this step and substitute in my c. Okay, if you get to that point, if you've done part B up to that point, you usually get all but the last points that you need. So if you can do all of that, you're going to get all but 1 point. Now we have to get y by itself. So I'm going to raise both sides to the e. Remember, this would be a quantity. And we do that because natural log and e are inverses. So I get the absolute value of y minus 1 equals e to the negative 1 over x plus 1/2. Then remember, to get rid of absolute value, we throw in plus or minus out front. And then I would add 1. So to find the exact solution that we need, we have to figure out, do we want the plus or the minus? And if you remember, we plug in our initial point. And our initial point was that x is 2 and y is 0. So when I put 2 in for x, I get negative 1/2 plus 1/2, which is 0. E to the 0 is 1. And remember, do we want positive 1 plus 1? Or do we want negative 1 plus 1? Remember, we want to get a value of 0. So in this problem, we want 0. So f of x is equal to negative e to the negative 1 over x plus 1/2 plus 1. That's the answer to part B. We needed the negative value. Okay, the next part, letter C, says for the particular solution y described in part B, find the limit as x approaches infinity. Whatever you find in part C, make sure you do this problem. Even if you come up with a BS answer that you really think is totally wrong and definitely can't be right, you still want to do this. Because whatever you use in part B, if you do it correctly in part C, it should count. So back to my f of x, I'm supposed to find the limit as x approaches infinity of this function. So if I put infinity in here, 1 divided by infinity, we've talked about, is really, really small. It's like having nothing. So I really get negative e to the 1/2 plus 1, because this 1 over infinity is pretty much 0. That's the answer. So even if you got part B wrong, if you use part B correctly for part C, you would get the points. Okay, so that's a lot. Hopefully you were able to follow along. Use these same strategies when doing the other two problems, FRQ problems in the packet.